Okay, here is problem number 4, one that's probably going to be there. We actually hope it is. They give me a differential equation, which gives me the derivative for a function. And they ask me to provide a slope field for the points provided. Now, I haven't seen them ever ask for more than this now. They asked for 6 points. So basically, it's an x and a y, and a dy dx. So pick the first point they gave me, which is 0, 0. I would fill it into the slope formula, which would be 0 squared over 0 minus 1, which is equal to 0. So the slope at that point here is going to be 0. I can write down all the other values I need. 0, 1, 0, 2 has a slope of negative 1 and negative 4. That's by plugging those numbers into that equation. And then my other points are 2, 0, 2, 1, and 2, 2. And I get values of 0, 1, and 4. So remember, the negative ones have to go down. Negative 1 is about 45 degrees. 2, it doesn't matter exactly. It just has to be slopier. That's pretty good. And the other ones have positive slopes. 1 is positive 45 degrees. This is slopier. And there we go. We've got our slope field for part A. Yay! Okay, next part says, let y equal f be the solution to the differential equation above that has a condition of f of 2 equals 3. Write an equation for the line tangent to the graph of y equals f of x. I'm going tangent to this line right here. So that would be my line L at x equals 2, by the way. Equals, to get a line tangent, it's f prime of c times x minus c, and forget u, f of c. So in order to find this information, I'm just going to fill them on in. My c is 2, so L equals f prime of 2, x minus 2, plus f of 2. Don't be tricked by this term right here. That's just the y value, and they gave it to me. They told me that when x was 2, y was 3. And what was the slope at 2? The slope at 2 was, the slope at the point 2, 3 would be, I just fill them on into the slope equation, which would be 3 squared over 2 minus 1, which would give me a slope of 9. That's my linear, my line tangent to the graph. Anytime I have to go a tangent line, I'm using that equation. It says use this to approximate f of 2.1. f of 2.1 is approximately, we can use the line to approximate it, 9, 2.1 minus 2, plus 3, which is equal to 9 times 0.1, plus 3, which is equal to 3.9. As long as I have the one approximate sign, I can use equals through the rest of the way because they indicate that the problem is approximately equal to. Okay, so the last part says find the solution to this particular equation, which means I'm going to be solving a differential equation. Make some room here. With the initial condition 2, 3. So I'm going to write down the initials. One here, dy over dx equals y squared over x minus 1. If it was a pocket rocket problem, I wouldn't already know what the answer is. But what I'm going to do is I'm going to cross multiply to start. So I get x minus 1 dy equals y squared dx. And it's our worst case scenario because the dy's and dx's are not matched up to their sides. So what am I going to do? I'm going to multiply this side by 1 over x minus 1, and this side by 1 over x minus 1. They're going to be gone from there. So I now have dy equals y squared times 1 over x minus 1 dx. Now I've got to do both sides by 1 over y squared. Or if you're like me, if I know it's y squared on this side, it's y to the negative 2 on the other side. I can just move it over, or I can divide both sides. And I've got y to the negative 2 dy equals 1 over x minus 1 dx. And this is pretty much the standard way they do this. One of the things can be a fraction that's probably going to be an ln, and the other is going to be some sort of exponent. It might be a negative exponent, but we only want to have a fraction if it's 1 over something that we can ln. So I'm going to quickly look. I separated correctly. Now I'm going to integrate this equation. So I'm going to integrate this side first. So it's y is going to go up to the negative first power, the negative on the outside, plus is equal to, the derivative of the bottom is 1, so I'm good to go. I can ln this, the ln of the absolute value of x minus 1 plus c. That's my general solution right there. We do not have to get y by itself. We can just get it into this format. And then they ask me to find c when I know that x is 2 and y is 3. So I'm going to substitute those in. Negative 3 to the negative 1 equals ln of the absolute value of 2 minus 1 plus c. They'll never give you an ln that's hard to compute out. You can do this one of a couple ways. I think the easiest way to do it is not to try to solve anything. You can just get this value by itself. I need to make some room. Hang on a sec.